All right. So, hi everyone. Welcome to Office Hours, or welcome back. So I think everyone's been here before, but I'll just recap for the recording. So we started this program last year to connect cloud networking experts with people who wanted to learn cloud skills. And we've had some really good speakers on so far, so it's been really fun. So today's topic is real world cloud networking deployment issues, which is really fun, but I'm not going to say it 5 times fast. I think I'm not quite equal to that. So just some housekeeping before we begin. So we really want to hear your questions. So please ask, raise your hand, unmute, or just drop them in the chat. And second, I'm going to drop a link to a survey in the chat as well that you can fill out to give some feedback and give us ideas for future office hours. Because today's topic, was requested by the community. So sorry, my dog is barking in the background. So we're really listening, and we really want to hear your ideas. So our host today, or my co-host, is John Smoker. I'm Alicia Pollard. We're kind of filling in for the traditional host, and he'll introduce the main speaker.
Yeah, so first I'll introduce myself, John Smoker. I'm a principal solutions architect with our ACE team. That's our ACE certified engineer program here at Aviatrix. And I've been with the company now for a little over 3 years. And automating and deploying Aviatrix cloud networks and use cases for our sales and marketing demo events, as well as in-person trainings like our ACE program, Flight School, and AWS Immersion Days. Before I came to Aviatrix, I was actually an Aviatrix customer for the 3 years prior to that. As a customer, I implemented our user VPN, TGW orchestrator, and egress use cases. So I have some real world experience. It was a few years ago, but you can see a lot of my recent experience has been in lab environments where I can control all the variables, which is good and bad. So I'm excited to have Tim here with us today to help drive this conversation because of his experience here at Aviatrix in the field. So with that, I'll pass it over to you, Tim, if you can introduce yourself, give us a little bit about your background, and kick us off with the kinds of issues or challenges you see with deploying cloud networks.
Yeah, absolutely. Hi, my name is Tim McConnaughy. I am a technical marketing engineer here at Aviatrix. Before that, I was a cloud solutions architect here at Aviatrix. Been here for 2.5 years now. Before this, I worked at Cisco. I was one of their SD-WAN technical solutions architects. I was there for 6 years or so. I have my CCIE, so I'm pretty deep in the networking. I got into cloud networking just a few years ago, but I've been catching up quite a bit since then. So, and also working with myself and of course a lot of our customers, I've seen some definite trends in the challenges of deploying and maintaining cloud networks. So yeah, I guess we could just jump right into it. One of the biggest ones that I always see pretty much with all of the customers that I work with, and I'll start high and then we can get into the nitty gritty if we want to. But one I see a lot is the fact that all the CSPs are different, right? They do all the cloud networking differently. And it's usually the devil's in the details where people are deploying into a cloud that they've learned. They try to take what they've learned in that cloud and then translate it to another cloud. And, so they deploy and find that things work just completely different in that other cloud. As an example, things like VNet peering versus VPC peering, AWS VPC peering versus Azure VNet peering. There's a lack of route sharing in AWS VPC peering that is kind of on by default in Azure. So you see a lot where customers are, kind of, because everybody wants to get to automation, everybody wants to get to kind of the rinse and repeat and the repeatable architectures. And it becomes very, very difficult when you start moving between clouds to get a truly repeatable architecture. You end up kind of creating the architecture at a high level repeatable, but then end up having to kind of do your own thing, do something special need for every cloud. I think that's the one I see a lot, and that feeds the skills gap that a lot of enterprises have, where they have a cloud team, but their cloud team is versed in whatever they've joined. So say, you're an enterprise and the first place you went was AWS. Your cloud team learned AWS, they're good at deploying at AWS, and then for whatever reason, say another cloud comes into it. That's really, really common, where you would see that kind of skills gap there. So I think those are the big ones I can think of just immediately, like just high level, right off the top of the head. The ones that trip up a lot of customers is just that translation between clouds.
Do you find that a lot of customers, as they're moving into the cloud, that it's the same team that was responsible for on-prem networking that is having to learn this new skill of
Mhm.
cloud networking, or is it a different team that they have to work together? Like how are you seeing that in the field?
Yeah, so this is a really interesting question, because if there is a trend, it's got to be one of those where it's like split completely down the middle, right? So in every enterprise I work with, it's literally one or the other, right? There's never this blended, and I'm sure they're out there, right? But hopefully more and more as we get into more platform engineering, where we build these kind of full teams where everybody's they're all part of the same team, for infrastructure, if you will. But traditionally, what I've seen mostly is either it's the network team, the on-prem infrastructure network team, that has to learn how do I connect to the cloud, and they have to learn just basically enough to get that connectivity, and then enough to let the developers not blow everything up while they're while they're testing and building. Or it's, here we have a very mature cloud team. They know the cloud very well, whether it be one or multiple. And actually, where they're falling down is in the reach back, because they're not networking people. So,
Mhm.
and when I say what I mean by the reach back, of course, is that bringing it together, that hybrid connectivity piece, is where they fall down, right? So what you end up with is, in both cases, actually, assuming there are two teams, right? Let's assume we've got an enterprise that has a cloud team and also has a network team,
Mhm.
right? And it's not one trying to do the other, or both, which is probably more to the point. What you end up seeing is that these two teams don't really speak each other's language, and so they're both right and they're both wrong in terms of trying to orchestrate what the hybrid connectivity should be, right? Like the cloud
Mhm.
team is thinking, well, CSP XYZ said the best way to do a hybrid is this. But the on-prem people are like, that's Greek to me. I don't know what that means, but here's what I know about how to connect
Mhm.
circuits together. Here's what I know about how to connect WANs together for hybrid connectivity. And it works out. These guys, they figure it out, but there's a huge amount of complexity in it, assuming even that what you're doing, even assuming you have one team that actually knew both ends of the puzzle. There's still a large amount of connectivity complexity, even if you knew both ends of it. So to answer your
Mhm.
question, yeah, what I see most of the time is where it's split one way or the other. um, I'm seeing more and more, like with really, really mature organizations, and certainly as the cloud has become more mature, you're seeing more platform engineering, where you've got teams that are again comprised of the network team, the DevOps team, the cloud team, and they're all on the same team, right? So instead of
Mhm.
kind of being at odds with each other, it's organized in a way that from a governance and management perspective, they're all under the same umbrella, and so they have to work together under that same governance.
Yeah, that's really interesting, and maybe if you could speak to where Aviatrix fits in here to kind of help these two teams,
Yeah.
maybe bridge that gap.
No, that's a very good point, right? So, and I was kind of working my way to it, and now obviously this isn't necessarily a sales pitch for Aviatrix, but one of the things we do very well is bridge those things together, right? So your cloud team and your network team don't necessarily have to become one team. Now, if they are, there's 100 other things that we do, but do on top of that. But hybrid connectivity, like I said, even if everybody knows what they're doing, tends to be very complicated because it always involves multiple vendors, right? And so no matter what you're doing, even if you're experts, you end up having to work over here with this vendor, work over here with this vendor, work in this CLI, work in this UI, and stitch it all together in whatever kind of Fisher Price connectivity options that the providers, the vendors and providers have kind of said, like, because a vendor's always going to focus on their view, if you will, of the world, right? So like like Equinix or something, or Megaport or whatever, as a middle mile provider, their center of gravity, of course, is the fact that they can, here's my connectivity option, and I can connect you to the cloud, and I can connect you, to your own data center, right? And so anything you do with that provider is going to be from that lens versus, so, okay, now I'm on-prem, and my on-prem connectivity is, the center of gravity is a completely different center of gravity, right? My center of gravity on-prem is my data center, or wherever my data is living, and my users that I'm trying to connect to the cloud to get to the data, right? Depending on your migration journey. Or from a cloud perspective, from the CSP perspective, of course, their center of gravity is right there on the cloud, and every one of those is saying you can connect to any other environment with using our kind of barely useful blocks that we provided to make those connections possible. So where we come in, and where our the Aviatrix value in hybrid connectivity is, we actually just don't care about what your connectivity looks like. You can use these barely there kind of connectivity blocks and stitch it all together, and then we will come over the top with all the, and we'll manage that complexity of orchestration, of connectivity, of route scale, and all the things that they couldn't agree on from a limitations perspective, right? We don't care, because we're coming over the top of it, and saying, we bring that unified connectivity experience over the top of all of those, so that you don't have to kind of solve for the lowest common denominator and just make it all work that way.
Yeah, hearing you talk about that is, I just had a thought about how, you're talking about, every vendor is going to have their point of view, and these teams are going to have their point of view,
of course.
And I think that's why it's so important to kind of lead with architecture first, regardless of solution, because otherwise you just end up with everybody choosing all of these different things, and it's just a mix and match set, and really hard to scale that kind of thing.
Yeah, well, and also not just that, but not only are they having to work together from their own points of view, but of course, when that happens, a lot of time it becomes, well, my point of view is better than your point of view, and so we should do it this way and that way and the other way, and that, when we talk about real world deployment challenges, before we even get to the point where we're clicking Terraform apply, we have like real governance problems to deal with, like who actually is in control of whatever the thing is that we're doing, and ultimately who's making decisions. Is it going before a CAB, a change approval board, where it's made of multiple business entities that have to work together to figure this out, or is there just kind of an iron fist, my way or the highway kind of organization, central IT, if you will, setting the direction? So you want to talk about real world cloud deployment challenges. The very first one you have to figure out is, who has the input into what that deployment looks like. The architecture first model, like you just mentioned, right? Architecture first. Who decides the architecture, and who signs off on it, and who kind of puts their blood on the line and says, this is the architecture we're going with, and all of you either fall in line, or is it more like a collaborative effort where we kind of all figure out what is the point of view that we're going to agree on? So that's the the very first, I think, challenge to solve. And one thing that, Aviatrix does do for you is say, everybody's speaking the same language now. You're all speaking Aviatrix. So we don't have to make this decision. We can have it all kind of idea. Which is literally like why I think why we exist as as a company, is to give people the kind of optionality to build over the top of all of those viewpoints with a center of gravity that's kind of distributed, if you will.
Yeah, I mentioned that I, came from a customer. We were a startup, 100% in the cloud, and a 100% developer-driven organization. So it was
Very common.
just teams of developers, and they had their accounts that they had full control to pull whatever it was off the shelf.
That's right.
It was really inefficient because you had these teams having to learn networking first. We'd spin up a new team and they would spend all this time just like trying to figure out the things. And so that's why we ended up bringing in Aviatrix, was to give us an architecture, a standard. We're going to do this in these ways.
Yeah.
And it really freed up our developers to develop applications, not
not worry about networking, right? And one of the big, and you actually touched on another of the big challenges before anybody hits the apply button, is that usually by the time the networking team or cloud team necessarily are getting involved here, there's a brownfield deployment that a bunch of developers have been using for years as a brownfield test bed, and so they've enjoyed the agility of running a credit card and just building whatever they want and not caring about security, not caring about more than basic connectivity. Let's put our prod and dev in the same VPC and call it a day because it works, right? And I can check my prod, I can check my dev, and everything's great. Oh, but wait, what, security doesn't like that idea? Why not, right? So again, getting back to a little bit of the governance that informs the architecture. That is another huge deployment. Is the challenge is that almost never are you dealing with a greenfield. The only time you're dealing with a greenfield is when you're a company that's been in, say, I don't know, AWS or Azure or whatever, exclusively. And now for whatever reason, maybe we're adding Gen AI workloads and we're going to do OpenAI now. We're going to add Azure, right? And so we're going to deploy Azure, and now we have the ability to dictate, what does Azure look like from the beginning, and what lessons have we learned? And usually it'll end up being different than this brownfield mess where you started.
Yeah, we were AWS only, and every day I lived in fear that somebody was going to say, "Hey, we've got 2 weeks to get over into Azure or somewhere else because we need this machine learning, or we need something that AWS doesn't provide, or doesn't provide best of breed."
I think I saw, was there a question I think that came to the chat here? Let's see.
Yeah, one question in the chat from Mohammed.
Yep. Let's see.
Yeah, would the architecture design challenges to be simplified will be factor for CSP along with migration at existing architecture?
Okay.
So let me,
yeah, let me see if I can understand that. So would it be simplified, be factor with the CSP along for migration of existing architecture? I don't 100% sure. I don't 100% know if I am answering the right question here. But I think what we're asking is basically, could we simplify the challenges with cloud deployment by migrating the existing architecture to something more standard? Is that accurate? Okay, brilliant. Yeah, so short answer is yes, right? Like, I mean, obviously the easiest way to solve your brownfield problems, I say easiest, that's the wrong word. The simplest, not the easiest way to solve your brownfield problems is to unify around an agreed upon architecture, right? And that does eventually have to happen. I don't know a single organization that has spent more than 6 months in the cloud that can say, oh, we're just winging it, like, at this point, right? Like, anything that's critical, anything that's business impactful, that's real in the cloud has to be given that level of consideration, right? So it's not a playground, right? Remember, the cloud started as a playground, right? Devs can quickly prototype, quickly build, and then bring it all. And then once they figured out if it works or not, right now we can bring it back on-prem, and they can build it in the slow kind of moving environment where they actually operated. And over time that kind of migrated more and more to, hey, we built it, let's deploy it, and whatnot. So yes, short answer is obviously migrating the architecture to a standard model will solve a lot of these challenges. However, now we talk about, again, with cloud deployment challenges, what about the challenge of deployment, right? So, or not deployment, sorry, of migration. The cloud does give us really good ways to migrate, though, right? If you think about it, if you've architected your apps in a way that they are loose, right? So all the CSPs go for loose coupling, right? They talk about loose coupling. It's one of the AWS pillars in the framework, well-architected framework. They talk about loose coupling, right? Take the apps and move them away from each other, right? And then use things like load balancers and stuff like that to separate the app communication and also to scale the app communication. So if you've done that, let's assume that you haven't, but like, let's say if you have done that, then it makes the whole unification of architecture much more simple, because you can pull out things and put in things, and you don't care because it's the load balancer that's taking care of, whether you're pointing at the old thing or the new thing, right? So again, loose coupling gives you that freedom to swap out old and swap in new. I won't say seamlessly, right? Obviously, but in a much more controlled way than you could if we were saying, this is server A, this is server B. I'm just going to flip the switch. You're now pointing at B, and I hope I did everything right. So, and that's another thing that Aviatrix does is give you the ability to migrate from a fully brownfield architecture slowly into an integrated, hub and spoke type of Aviatrix architecture where it's multi-cloud and all of that, one at a time without having to fully commit all at once. So short answer is yes, you can do it, and the way to do it is slowly, kind of piecemeal, but the cloud does give you the agility to be able to do it without a lot of impact, and not, unlike DCs on-prem DCs where you really had to spray and pray.
I was going to say that's such a different experience than what you have, and so you moving to the cloud is your opportunity to kind of make up for some of the things you were stuck with on-prem for all these years, just because it was difficult. To shift like that.
Excuse me.
So another question from Saeed. Do you want to just ask the question, or you put it in the chat, but please.
I could, yeah, it's up to you, Saeed, if you'd like to, or I could just read it. That's fine too. Okay. Let's see. So how does Aviatrix position itself as an intermediary to facilitate seamless integration, enhance security between multiple CSPs, third-party vendors, when collaborating, and what unique approaches? Yeah, you don't ask a small question, do you? That's a good one. It was a great question, right? Like, I want to make sure I can hit all the high notes because you've put quite a lot in here, but like, okay, so let's just start with the first part. So how Aviatrix positions itself as an intermediary and I touched on this a little bit ago. The biggest thing is that we are overlaying whatever architecture you are already using, right? So that's the very first thing. So, if you have, I don't know, a direct connect or express route, if you have an internet VPN, whatever underlying connectivity that you have to the cloud or on-prem is not as important for us, because we can build a unified architecture on top of that. So that's like the very first thing. And so when we talk about being an intermediary to do the seamless integration, we kind of have the advantage that all overlay type of solutions have, which is that we can dictate a fabric on top of pretty much any underlying connectivity. We could do, a tin can and string if it can carry a packet, right? So that's the idea. Like, so that's the first part of your question. So hopefully that part at least makes some sense, right? Between multiple party CSPs and third-party vendors, for example, we have Equinix, which we have a Equinix Edge that we provide. Equinix being a excuse me, middle mile provider, they can connect to pretty much anyone, anywhere that Equinix can get a packet to. So we, with our Equinix Edge offer, literally are a seamless intermediary between anything that any enterprise chooses to leverage Equinix to connect to, just as an example, right? Or commercial internet. You could use a DSL or cable or whatever, like for a business. We could do mall kiosks, whatever. It doesn't really matter. That's the first part. So what unique benefits does it offer? So that's to anyone that's organizing multi-cloud environments. Obviously, the biggest one is that you get the seamless. I keep saying seamless. Sorry. I'm not sure what other word to use here. Literally, you get the single, and I'm not going to say pane of glass, the single experience of owning a fabric that is end to end the same experience, right? So Aviatrix is handling the actual every cloud specific weird kind of way of doing things because we're orchestrating it. And because we're orchestrating it, the only thing you as a customer have to worry about consuming is the service itself, the overlay piece of it, right? So that end-to-end connectivity becomes visible, which is obviously a huge deal. If you're going between multi-cloud, it's a huge deal. But also, so we could troubleshoot it. You could do packet captures directly on the wire. You could do a packet capture between Azure and AWS, right? So that's something you really cannot do with the native offers or many of the other ones that are out there. So we talk about unique benefits. The biggest unique one, again, is that sameness of experience from one end to another, whether it be in one cloud or multiple. And then, of course, being able to see the whole path obviously is a big deal. You asked specifically about multi-cloud environments. Of course, anything I just said is like doubly hard in a multi-cloud environment because you can go to the AWS console and do VPC flow logs or whatever, and then okay, great. Well, once it's left that VPC or once it's left AWS, like I'm boned, right? What do I do now, right? So then you can go over to the Azure console. All right, well, let me go look at Azure and do the troubleshooting there, the diagnostics, but it lacks the sameness of experience. Like even from a perspective of what metrics we're looking at in CloudWatch versus the Azure monitoring, right? So it's very hard to build that same view. If your app owner is calling and saying my app is having a problem, my database, my OpenAI, I'm feeding stuff to OpenAI in Azure from some workloads that I'm doing some ingestion or OCR or whatever it is that I'm doing in AWS. I'm feeding that over into OpenAI. Like what's happening? Without a unified experience, is very, very difficult to stitch that all together. I think.
Yeah, and I just want to add that issue isn't just if you're multi-cloud. Even in a single cloud, like multiple VPC, multiple accounts, having to aggregate or correlate flow logs across those things is just as difficult as between Azure and AWS or another cloud, I should say.
Absolutely. Very good point. Saeed had mentioned multi-cloud, and so I focused there, but you were absolutely right. Correct, John. Anybody who's ever gone into any of the CSP's consoles and tried to like pull together all of the different troubleshooting tools and get that single idea of what the hell's happening. Oh my God, it's rough. I mean, it's rough. Well, it's good.
Yeah, and again, speaking for the company I worked with previously, we were spending time building tooling around doing that.
To do that. Yeah, absolutely.
And so anytime you have your teams building tooling and then maintaining tooling, that's time that they're not doing things that make your business money, right?
Exactly. I was going to say exactly the same thing. You're not generating revenue if you're too busy dealing with that. So yeah.
Well, I always want to bring that up in these conversations because I think we don't think about them those costs like up front when we're having this conversation. So I think it's an important call out for sure.
Yeah, I think Teams actually explained. Sorry about my long questions or multiple questions.
No, it's great. It's good.
The thing is like, because I've been on-prem network IT guy for the past 20 years anyway. So the thing is like, I'm I'm kind of, just transitioning, which is not transitioning, but I already been there to the cloud. But
Mhm.
what really, just attract me is Aviatrix is actually, with a centralized console that you can, stitch up all these multi-cloud environment, which is, just you know, um, I know, just there is other parties that actually do that. But the thing is, like, just what really attract me with Aviatrix is kind of a unique. That's why I put that word into
Mhm.
my questions, the unique part of it. And you really, just pinpointed exactly what I need for the answers, which is, quite amazing. I mean, Aviatrix is actually doing kind of unbelievable work. And
Yep.
I don't know how the clients are there could not even see it and said jumping into Aviatrix and says, wow, that's exactly what we need. In terms of the troubleshooting tools and all that stuff, Aviatrix actually do have it.
Mhm.
Um, it is fantastic. I mean, that's I'm learning a piece on there, all trying to stitch up all my learning uh, styles. He says, okay, I can put this one into this one, but Aviatrix is actually trying to provide me all that, and
Mhm.
this is fantastic. So that's why I said, okay, I better be today knock off from work. I'm working from home, but says I'm not doing anything. I'm
Spend a
gonna
few
go to this
minutes. Yeah.
meeting. Yeah.
No, I'm
Fantastic,
glad you.
Tim. I really appreciate that. If I do
Yeah,
have any other questions that I'm learning from you guys,
please.
I'm gonna, yeah, I'll speak up. I'm not gonna write it down again because my question is always a bit longer.
I'm okay. It
Well,
was actually an excellent question. I thought it was an excellent question. I just want to make sure I addressed all of the pieces that you had asked. And also, have you done our any of our ACE training that
Yeah, yeah,
John mentioned? Okay.
I've finished it already.
Oh,
I'm
oh,
just
brilliant. Okay,
yeah, I
okay, got
already
it.
finished.
Oh,
It
brilliant.
was great, but my kids actually say, "Daddy, you're always studying. What's going on?" And I said,
I know that
"Well,
deal.
tell the technology is rapidly changing or evolving. I have
Yes.
to keep up with it."
The treadmill is real. That is,
Yeah,
I mean,
yeah,
that is something
definitely.
we're trying to help with is by giving that, so you don't have to learn 5 clouds. You could just learn one product and a little bit about the clouds, and so that is definitely a huge deal, right? The skills gap piece. And I'm right there with you, man. I'm right there on the same tech treadmill. We all are on that same
yeah,
tech treadmill.
yeah, yeah.
It's
Sure,
eternal.
sure.
So we do have another question from Mohammed. How to improve connectivity, latencies, and bandwidth?
Oh, okay. So great question. Specifically, again, this is to do with cloud deployment challenges and whatnot. One of the biggest challenges with improving latency and bandwidth, right? The is especially with native connections, and they work fine. There's nothing wrong with native connectivity, but a lot of times because they are so sort of looking for kind of just basic, really, like there's a basic, so either they're offered in one of two ways, right? It's either here's your basic connectivity and we'll kind of scale, this is what we offer, but like, we offer resiliency under the covers, but your connection is what you get. So like, for example, the AWS site-to-site VPN, perfect example, right? It's a 1.5 gig connection, like limits of single IPsec. You get redundancy with it. 2 VGWs, assuming you have 2 devices on your side, you get that basic redundancy, but that's your offer, right? I believe Azure actually does a little bit better based on the different SKUs that you can do different stuff. I'm sorry, I'm not as great on all the little Azure offers as I am with AWS. But I know that there are SKUs and that they severely, like they have a big impact on the things like redundancy and also the bandwidth that you can get through those. So just using them as an example, right? So they're very basic. That's what you get. So what that means that from a bandwidth perspective is that if you want to scale out bandwidth, you have to choose either another connectivity solution, one that offers more bandwidth. So for example, ExpressRoute or Direct Connect or something like this, right? Or you have to start scaling your VPN connectivity or something like this. So if you're using internet, for example, you can land it on a TGW in AWS, for example, or vWAN in Azure. But again, there's still that limitation there. So what you end up having to do is more. You just have to do more. And then that means you have more to manage. And you have to try to figure out from a routing perspective, how do I make it do equal cost? So I'm actually utilizing all this extra bandwidth. There's a lot under the cover of managing and creating extra bandwidth, right? And latency is another thing. I'll cover that in a second, but just the actual overhead, if you will, of managing getting more bandwidth, unless the circuit that you're using already comes with a sizable amount of bandwidth, is quite complicated, right? So for example, you might have to do multiple site-to-site VPNs, and again, then you have to do things like route, try to figure out how to weight your routes and stuff so that you can take advantage of that extra bandwidth. So and then for things like I said, like for the express route, direct connect, fast connect, all the CSP offers, that's not about bandwidth. Like that's just, so you get between a sub rate, you can do sub gig or 1 gig, 10 gig, whatever, 100 gig. That's not about bandwidth. That's just straight connectivity. The challenge with that is if you're in a regulated industry, depending on what encryption availability there is on those circuits, it may work out or it may not. So that's not something we really think about when we're as network people thinking about bandwidth. We're just thinking about straight, like how many packets can I fling across this wire? But security is a big deal, and the security team, obviously cares quite a lot about it. So if you don't need the encryption, you can do, here's my direct connect. It's 10 gig, 100 gig, whatever, and we can connect as long as both ends of the connection support it. If we need any kind of security, so in some cases we have like MACsec, some connections offer MACsec, which is kind of a layer 2 MAC encryption. A lot of times the vendors that support MACsec charge quite a lot for that feature capability. So anyway, so long story short, how we solve it here is we actually do something called high performance encryption, where we actually orchestrate and manage the load balancing of multiple lots of IPsec tunnels, so that we get the full encryption, like layer 3 encryption, end to end, not just one hop like you do with MACsec. But you're not having to build 10 VPN tunnels and figure out how to balance it. Like our product is already handling all of that encryption and all of that bandwidth acceleration for you. Now, from a latency perspective, I mean, latency often is something that you can't directly control. You can control to some degree. So for example, if you are connected over a direct connect and or express route, whatever, often you would expect, and there's an SLA associated with that, where you are getting a commitment from the provider that says you will be sub 10 milliseconds or something like that, right? Whatever that latency looks like, you usually it's like 1 or 2 milliseconds. It's very, very fast. Versus something like a site-to-site VPN, where you're running over the internet and there's no service level agreement at all. Really, at that point, the only thing you can do to improve your latency is hop onto AWS backbone closer, or I say AWS, but whatever the CSP backbone is, right? So not trying to make a connection from, say, France and then connect to a site-to-site VPN that's in Northern Virginia or something like this, right? You would want to connect to a POP for your chosen CSP in that country as close as possible, really, as close as a zone as you can get, so that you're minimizing the amount of time you're spending on that non-SLA bearing circuit, that whatever best effort internet circuit, right? And then at that point, you can ride over the CSP's high speed backbone. So the biggest way to improve latency is to minimize the amount of space between where you want to connect and the on-ramp, if you will, to whatever it is that you're ultimately trying to connect to, I would say. And, that's something that we do with Aviatrix Edge. We do middle mile, like, Equinix, for example, or you can even do, we're calling Aviatrix Edge as a platform. So, you can actually rack a device in your data center, for example, and go straight to the cloud from there, there. So.
Yeah, and just to add on to the latency thing, you mentioned ways to choices you can make to
Yeah.
improve, but I think a lot of times just kind of knowing what the latency is a big deal.
Yeah.
And that's something that you get, between Aviatrix gateways, just real time
Yep.
built in. And it's important to know to help you make these decisions about
Oh yeah.
how you architect or connect your applications, but also if latency changes, like you mentioned, if you're going over the
Yeah.
internet, you don't have any SLA there. But if
Right.
it's working most of the time and then all of a sudden it's not working, well, why isn't it working? And you can see that latency has, gone from 10 milliseconds to 100 milliseconds, and now
Yeah.
you understand, okay, this is why we're not performing. And just having that
Absolutely.
feedback in real time is I think pretty huge.
No, that's a very good point out. And a lot of times with a lot of customers, what they do with us is, we'll architect. We when people architect with Aviatrix, they tend to surface problems that they didn't see before. So that being a
Yeah.
very good example of one of them. I've had multiple customers where they were part of the reason they even started looking at us was they were having application performance problems that they couldn't diagnose. And after the fact, you find that, oh, actually, the way you've architected this connectivity is pretty substandard, and we're seeing it in the latency monitor of our Aviatrix gateways, for example. So there's a lot of cyclical design is never done, right? It's very, very cyclical.
Yeah. Yeah, absolutely. Yeah, just a quick anecdote. I was on a call with a customer, and we were just talking about, they had a presence in I forget exactly what it was, like OCI Arizona and AWS US East, let's just say. And they were just speculating about, like, well, if we, connect these, what's that experience going to be like? Would we even be able to do this? And that kind of thing. And as we were talking, I just deployed 2 transit gateways in each of these zones, connected them together, and then was able to give them the feedback of, hey, it's about this many milliseconds between these two different cloud data centers.
Yeah. And yeah, I mean that level of troubleshooting is one of our most popular use cases, just to give that level of visibility, especially as more people move their crown jewels, to some kind of
Yeah.
cloud deployment. It's extremely important. Again, with loose coupling, where it could be
Yeah.
any one of the things along the path that are having the problem
Yeah.
too. So yeah,
Yeah.
absolutely.
And help you
Yeah,
choose regions and clouds to be in,
Yeah,
based off of this feedback.
I
absolutely.
think
So just
I think
just just
yeah, sorry.
oh, go ahead. Yeah.
Go ahead, Sig.
Yeah, I think Tim's actually, just answer most of the questions. But one point that I've actually picked up was the SLAs.
Hmm.
So which part of the party, either Aviatrix or the customer or the third party vendor, where
Hmm.
the SLAs actually falls into and the SLOs falls
Hmm.
into, because
Hmm.
those two is actually always trying to interact. So between the vendor, the person who's actually providing the
Yeah.
service,
Yeah.
and the receiver. So the SLAs and SLOs there. So
Yeah.
most of the time in IT world, I know you guys been in the IT world, for quite a long time, and
Hmm.
the SLOs is actually, just missing in that part, and everyone is talking about the SLAs, which was a good point when you've actually trying to answer Mohammed
Hmm.
questions. And I've got a question you because you mentioned security, and I've got things in my mind to ask you before we wrap up. And
Okay.
yeah, so yeah, where is the SLOs actually falls into in that part?
So are we asking, make sure I understand the question. Are you asking
Yeah,
who's responsible for those
Y-
in this
yeah,
deployment? Okay, that's fair.
yeah, yeah,
So Aviatrix often, so it depends on obviously, just like always, it always depends on where the problem is. Like, what is the problem? Obviously. Let's assume that the more common one is that there is some connectivity issue between point A and point B. And let's say that we have an Aviatrix overlay built on top of the connectivity between point A and point B. So um, depending on what the problem is, so Aviatrix may or may not be able to diagnose that for you. So if it's intermittent or if it's something where it's happening, say every 30 seconds, or a flap, like you're an on-prem guy, right? Like a routing flap or something like this, or routing loop or something. You would see that intermittent connectivity piece where we're connected, we're not, we're connected, we're not, kind of on that schedule. Like that would be very, very clear. Like, okay, there's a connectivity problem, whether it be an actual physical layer problem or a routing layer problem where the provider, whoever it is, has maybe done something. So there, Aviatrix may be able to help, because you would see the behavior in the gateways themselves. Like you would see, not the gateways themselves, like they would be going down and coming up, or it depends. We've had AWS outages where say like, God knows US East 1, right? So we've had outages before where a customer lost their Aviatrix gateways in US East, and it turns out that, actually this availability zone in US East is having a problem, and AWS themselves had not even published that, hey, they're having a problem yet, like this has happened. From a connectivity perspective, the SLA usually follows with whoever's providing the connectivity, for obvious reasons, right? That should be very, very clear. From when the SLA and SLO usually falls on us, it would be something like, say if there was some sort of software issue with the platform, and we needed to apply some kind of fix, obviously, right? Something you would call Aviatrix support for, because Aviatrix as a platform is having a problem that you did not expect. Often what we find out is that while diagnosing the problem, there ends up being a CSP level problem, but certainly Aviatrix is not perfect. There have been times where, customer has surfaced some kind of problem, and we need to provide a solution, like a workaround there, but then a solution, like an actual solution, like a patch or some kind of fix long term. So it really ends up being a question of course, where is the problem as to who is going to own the SLA and the SLO around it. But we've never shied away. I mean, people call our support when they don't know who else to call, because they know we'll answer the phone and help them figure out what's wrong a lot of times. Sorry.
what are you showing us there?
Yeah, sorry. You're muted. I couldn't see it. I couldn't see it.
Sorry, I was actually just trying to listen to you at the same time, but I'm trying to get my notes. I've got all the notes that I need with Aviatrix. I'm a kind of guy who's doing multitasking all over the place.
That's fine.
But I really appreciate what you did. But there is a questions. After that questions, you've touched a security point that really, you guys did it now with AWS, which is I deal with them all the time, and Azure. I'm a multi-cloud also learning with all the four big major guys, the pillars. I'll call the four pillars now. So there's a question in mind that coming through, but I'll let the other audiences just ask questions.
I'll answer this last one, and I think this might take the rest of our time, but you can reach out after the fact, Saeed. We got your information and whatnot. You can always ask us questions, and it doesn't have to end right here. You can ask us questions. All right, so question that Mohammed had was how to control route traffic adjacencies between CSP or data center. So when you say adjacency, do you mean like the neighbor, like the neighborship itself, like BGP or something like this? Or are we actually talking about something else? Are we talking about maybe the pathing or the route preferencing? I think might be what you're looking for, but I'm not sure. Yeah, BGP, but okay. I'm going to assume that what you actually mean is the pathing, like choosing the best path, and not the adjacency itself. Because of course the adjacency is just based on making a BGP neighbor and providing the correct information between the CSP and the data center and the Aviatrix, right? So no, we offer multiple options. The easiest one is, of course, simple AS path preference. So we support BGP. Like a lot of the other providers have basic support of BGP. Our support probably isn't where it needs to be, but we're fixing that very quickly. We're gonna, we're bringing things like BGP communities and stuff for traffic engineering. It's not quite there yet. It's coming very soon. But right now you can do things like AS path prepending, which is the same kind of stuff that you can do just in basic BGP routing across any of your providers, right? So in terms of path preferencing, when we create BGP neighbors, especially with an extra cloud or an outside the cloud connectivity, whether it be Equinix Maybe you have a router in Equinix and we're peering with you over the direct connect or something like that, or over internet, or maybe we're talking about in your data center, whatever that is. As long as there's a connectivity between the two, we can form a BGP adjacency, and then we can do route preferencing based on you send us a certain amount of AS paths, and we'll honor that. We'll use that for traffic engineering. Again, we are getting a lot more traffic engineering options coming, especially with the advent as once we support BGP communities, which is coming soon. Just so you can do things like regional level path preferencing, which you technically can do now with AS path. We just feel that BGP communities, of course, always makes it a little easier. Any of the on-prem people, any of the people that are familiar with BGP and using BGP in on-prem should be familiar with that idea of that. So that's coming, but right now you can do AS path prepending. So for example, let's say you have two data centers and the data centers are connected over some kind of a dark fiber link. That's completely outside the cloud, right? It's just two data centers, dark fiber between them, and you want to offer redundant cloud connectivity for both of them. You can do things like send either a subset, like a supernet, for the other data center over your connection to us. And then, of course, we'll use the more specific route, just like you would expect, until a failure happens. Or, of course, you can use AS path prepending, where you send the same routes over both connections, and then you prepend certain routes. So you would prepend the other data center's routes over. So you prepend data center B routes when you're sending it over data center A, for example. This is kind of basic BGP stuff, right? So I won't go too far into it. But the idea is, again, that based on how you want to architect it, you can provide a level of BGP layer redundancy and resiliency. Just have multiple cloud connections through us, and we will honor those route preferences and route accordingly. Even in
Yes,
failover.
for example, if I want to block unknown route traffic from BGP, for example, unknown network for me, for there's a
Okay.
feature in the features you can use BGP route approve.
Yes, that's correct.
That
That's
one
correct.
for unknown and make security from that one. So how to, for example, how to do it with the other multi-cloud for specific CIDR or network from how can make it?
So of course, route approval works for BGP. So that just works. We're doing some we're adding the ability to do wildcards as well. That's coming soon, where we can do wildcard route approval as well. And so you'll be able to do supernets or whatever subsets of those routes as well. From an inside the cloud perspective, let's say the routes are already there, and for whatever reason, I guess we learned them. You can do it. You can filter it on the gateway, or you can filter it between transits. It's a little messy. I actually don't recommend it. I would recommend that we use route approval not to learn the route in the first place, if at all possible. Or on the side where you're advertising the route to us, obviously it may even be easier to filter it there, but we can support it. We can support this what you're talking about. Like I said, it's a little messier than I would like. It's just not very elegant, just because the route approval is really supposed to be the first line of defense. And then you start getting into things like statically filtering routes, which I personally am not a huge fan of statically doing anything. I would much prefer to dynamically take care of stuff, because once you've statically done something, we tend to forget it, and then it ends up impacting something down the line, and we don't remember we did it, and so we have to go fix it and hope that we figure out what it was in the first place. So that's so I don't know if that answers the question that you had. I hope it helps.
Thanks.
I think
I want to know about that one, if I can block it from unknown network. I don't want that network come to me. For example, in the hybrid connectivity, for example, data center or multi-cloud for each CCP. So I don't want to like do it. I want best only to block that one, but I want best like that. I want to make it a route, and also with the from that one, meaning I don't want to depend on the BGP attribute. I don't want to depend with the route BGP route approve. That one who can block, as you said, as a layer one, layer defense, then I can do it more.
So-
that one, thanks to that for explanation, that one.
No, great question. So two of the things I mentioned are gonna help a lot with this. One is gonna be the BGP route approval wildcard, where you can, assuming you know, are receiving something that you don't want to receive, you can filter it at a wildcard level, and also the BGP communities as well. Depending on how you're learning the BGP from BGP, you can, you know, you'll be able to take action based on communities or such as filtering, right, or traffic engineering. So some of that's going to be a little easier as we introduce a couple of these new features, which are on the horizon and coming. Right now, it's a little bit more of a static endeavor if you want to try to do unknown stuff, like say, and so that's my suggestion is a lot of these features are coming and you would definitely be able to do it soon.
Will be there anything for IPv6 traffic?
We are working on IPv6. Just, you know, I don't want to get into the roadmap because we're almost out of time anyway, but rest assured, IPv6 is a thing we are very serious about and we are working on right now.
Yeah, thanks.
Yeah, I think with that we're at time here. Appreciate everybody's you know, participation here. Tim, appreciate your expertise. Really good conversation. And thanks for hosting us, Alicia. Do you have any last thoughts?
Yeah, thanks for coming. Thanks so much, Tim and John, for your expertise. It's really helpful. So just the last two things are, please fill out the survey. We want to hear what you think. And then next month's end of July office hours are on the transformative impact of generative AI. So if you're curious about that, we'll have Mark Cunningham, our product manager, one of our product managers, to talk about that. So yeah, thanks everyone, and have a good Friday.
Thank you very much, Tim and John and Alicia. I appreciate it. That was very informative, actually, you know, trying to dig it more. But thanks, guys. I appreciate it.
Have a good weekend.
Glad you enjoyed it.
Cheers.
All right.
Okay.
Cheers.
Take care, everybody.
Okay.